Section 2.2 in advanced geometry. Starting off with some simple ones. Find the measure of each numbered angle and name the theorems that justify your work. So just got to talk ourselves through it in this problem. What kind of angles are 1 and 2, my friends? You get two choices so far. Linear pair or vertical angles. What kind of angles are they? Let's take this information and do what with it? Put it in the picture. Just put it in the picture is what I know what you're trying to say with substitute, but we'll put it in the picture. If they give you information and you have a picture, you should put that information in the picture. So now, this is from previous chapter. What should we do with those bad boys if those are a linear pair? Set them equal to each other is what a bunch of people say. Folks, we got to learn that. We got to add them together, set it equal to 180. So how many x's do I have? 4x. How many constants do I have? 28. That will equal 180. Justify it right away. We did a bad job of justifying next to the equation. What is our justification for this situation? Linear pair theorem says that's why we can write that equation. Solve for x. Help me out. Subtract 28, right? What is 180? Take away 28. Very nice. Then divide by fur. And fur goes in there 3 times with a 8 left over. Right, 38. Now, are we done? We're not? What do they want then? Measure of each angle, right? So how would we do that? What would we use? Let's substitute 38 back in for x, right? So we can do that mentally. What's 38 plus 10? So if I just write 48 degrees, is that what I want to write? Measure of angle 1 equals 48 degrees. And the measure of angle 2 will be 38 times 3. Probably better punch that in and add 18 to it. 38 times 3 is 90 plus another 24. So 114 plus 18, 132 degrees. I knew that before I even punched it in. If this is 48, that better turn out to be 132, correct? Why? They got to add up to be 180, so that's why you can check to see if you did your solving correct. Cool. Next guy, measure of angle 4 is 2x minus 5. Put that in there. Measure of angle 5 is 4x minus 13. Putting it in the picture. Then let's think. Since this angle is 90 degrees and this is vertical to it, shouldn't that angle be 90 degrees also? So let's add those together. How many total x's do we have? 6x, and then constant-wise we have negative 18. That'll equal 90. And where did we really get it all from? From the vertical angle theorem is really what set us going. We knew that they both had to equal 90, right? Vertical angle theorem is really the whole kit and caboodle there. So let's add 18 to both sides. Six x comes down. That's 108, right? And then divide by the 6. 6 goes into 10 once. There's 48 left over, so that's 18 times. Is that right? Then let's find the measure of each angle. What should they add up to be? 90. So I'll substitute 18 in here. I'll get a 36. Take away 5. Measure of angle 4 would be how much then? 36 take away 5, which is 31 degrees. Right now I know the other one better turn out to be 59 degrees, correct? But let's check to see if we did our algebra right. Let's put 18 in for this guy right here and make sure we get a 59 shooting out of that. Take 18 times 4 and then subtract away 13. Do you get 59 degrees? That means you did your algebra right. Cool. Next one, you and pal, get her done. Angle 3. Where's angle 3? Oh, good idea. Measure of angle 3. Yes, because they said find each measured angle in the situation. So measure of angle 3, how much? We're cool with this one right here. Measure of angle 3 is 90 degrees. Thank you. Now, you and pal, let's get number 3 done. So please pause the video, substitute in, set up an equation, justify, solve, and answer the question. So, since they were vertical angles, we set them equal to each other by the vertical angle theorem. We solved for x and got x as 19. Then we substitute that back in, and each angle should turn out to be the same, since that's what we did in the first place. So, 109 degrees. Next. Now is where I feel funny about doing these proofs so early, because these are the harder of the proofs that we want to do. Here's the normal process in any proof. You read the given, write the given, mark the given. But I don't want you to do that yet. The normal proof situation is read the given, write the given, mark the given. But there are 3 dirty words in this classroom. Dirty word proofs means we don't follow that process. The 3 dirty words are midpoints, bisectors, and circles. And we won't do any circle proofs for a long time. But midpoints, bisectors, and circles. If you see any of those given to you, that means we've got a whole new process. And that's weird because our very first major geometry proof here is a dirty word proof. So let's start like this. Read the given. They gave me how many things, my friends? 2. So we will put both of those things in our step 1, and we will write them on top of each other, and we'll separate them with a semicolon. So B is the midpoint of segment AC. You just write that verbatim. And C is the midpoint of segment BD on top of each other, and then you justify it with given. So pause the video, get those written down. If we have a dirty word proof, like a midpoint or a bisector or a circle is given to us, we just read the given, write the given. That's it. Now, if they give us any non-dirty information, meaning, are there any information given to us that does not have the word midpoint, bisector, or circle in it? Do we have any non-dirty given information? We do not. If we did have some information that was non-dirty, we'd go mark that in the picture. Okay? But here's how we work with dirty words. We're going to work one dirty word at a time. Didn't they give us more than one dirty word? Didn't they tell me that B is the midpoint of segment AC? So after we've got that down, we're going to mark that one situation in our picture. If B is the midpoint of segment AC, would you all be cool if I'm a highlighter guy? Please don't highlight, but just, isn't that segment AC right there? If B is smack dab in the middle of it, how would you mark that in the picture? Anybody know? Tick marks, right? So let's do that. Boom, boom. And now here's what makes it dirty is kids forget to go into the proof and write down what they just marked. Didn't we just mark something in the picture? Right? So step 2, what did we mark? We put a tick mark on this dude. What's the name of this dude? Segment AB. What was the other dude's name that we put a tick mark on? And what do the tick marks mean about those? That they are they can't be equal. Segments can't be equal. What do they have to be? They have to be congruent to each other. Segment AB is congruent to segment BC. Isn't that what we just marked? Cool? Why did we mark it? Because they told me that B was the midpoint, correct? Now remember, you can only justify with a definition, a postulate, or a previously proven theorem. Do we have any midpoint theorems? Yes or no? I've given you a theorem about midpoints. Name the theorems that I've given you. Theorems you know about. Vertical angle theorem, we know about that. Anything else? Linear pair theorem. And that's it, right? Those are the only 2 theorems that we have talked about. So do we have any theorems about midpoints? Nope. Do we have any postulates about midpoints? Nope. But do you know what a midpoint means? Yes or no? If you know what something means, that's its definition, correct? Isn't that why we put the tick marks on it in the first place? They said, hey, B is the midpoint. You're like, oh, well, this should be the same as that, correct? Isn't that exactly what it means to be a midpoint? So what's our justification for that? Straight up definition of midpoint. And here's how you can abbreviate it if you want to, if my pen would work. Midpoint, MIDPT is how we can abbreviate that. Definition of midpoint. And when you were writing stuff down at the given, you could always abbreviate that in there too, MIDPT, if you wanted to. Midpoint. Definition of midpoint. Is that cool with you? Now that's one of the given bits of information. Didn't we use this red midpoint, if you will? Do we have any other midpoints provided for us? So I'm going to use a green midpoint right here. Isn't this the midpoint of segment BD? You with me? I'm going to show you with a highlighter. Here's segment BD. Isn't C smack dab in the middle of it? So don't we need to put tick marks on this situation? But wait a minute. This already has a tick mark on it. Should we put a different amount of tick marks? Because let's pretend that it was 2 inches, right? If this was 2 inches, should it change to be like 3 inches or 5 inches just because I'm going to go with a different situation here? It's got 1 tick mark on it, correct? So if this has 1 tick mark on it, and this is supposed to be the same as that, how many tick marks does this guy get on it? 1 or 2? Well, it's supposed to be the same as this one, right? So let me use numbers for you. If this is 2 inches, shouldn't this be 2 inches? Isn't that what that means right there? Now, this says C is right smack dab in the middle of this guy. Well, this is 2 inches. How long's that got to be? It's got to be 2 inches. So how many tick marks should this guy get on it? It gets 1. It's got to have the same amount as that one already. You with me on that? So we have to kind of be careful about what we want to write down. Didn't we definitely put a tick mark on segment CD right here, correct? So segment CD comes down right here. But what was it the same as on this midpoint right here? Which segment was it the same as? Wasn't it the same as segment BC? Even though we didn't end up marking it, wasn't that the one it was the same as? So segment BC. How come segment CD is the same as segment BC? How come we marked it? Why did I mark it? Because of this. Didn't they tell me so right here? And isn't that what that word means? So what's our justification? Definition of midpoint. If they give you 2 midpoints, you should use the definition of midpoint twice. That's how it works. It's just that simple. If they give you a midpoint, you will use the definition of midpoint. If they give you 2 midpoints, you will use the definition of a midpoint twice. How many midpoints did they give me? 2. And then how many times did I use the definition of midpoint? Twice. I haven't even looked at what they want us to prove yet. All I knew was they gave me 2 dirty words. I wrote the given, then I didn't mark anything. I went through each dirty word at a time and marked what they meant and wrote them down. Now, this is what they want me to prove, correct? Well, let's see what we got going on. They want segment AB, which is this guy right here, to be the same as segment CD. Isn't that what they want? Question for you. Are they marked the same in our picture already? You know what that means? That something in here is cool. Look at what we have written down. Segment AB is congruent to segment BC. We also have segment CD congruent to segment BC. Do you notice anything about those 2 statements? Segment BC is common to both of those. What can we do with stuff that's common? We can do the transitive property, which means we will do what to these guys? Cross out what's in common. I want to see you physically cross them out. Now, don't black them out. Watch me cross them out. Newt, Newt. Can I still see what's underneath there? I want you to cross those out. This is blacked out. Now, how can I grade that? I can't see what you wrote underneath there. You with me? So we cross out what's in common, and we write the leftovers congruent to each other. How come congruent? Well, that's because what we were using. Right? We're going to stay consistent throughout the proof. There's no equality going on. It was all incongruent. So you definitely told me that that's what property again? And you will not abbreviate that. It's the transitive property. Now we have 2 of them. There's a transitive property of equality, and there's a transitive property of congruence. Which one will we be using in this case? Because we were using congruent symbols. Woo! That's our very first proof. It ended with the transitive property, and it was a dirty word. There are 3 dirty words: midpoints, bisectors, and circles. To handle a dirty word proof, you write all the given down, then you go 1 dirty word at a time and mark what they mean. Let's try again. Is this a dirty word proof? Yes or no? You have to look at what they gave you. They gave me a bisect, correct? So we read the given, we write the given. Ray DB bisects angle ADC. Reason for that is what? Given. That's free points right there, baby. Now here's the thing on all these dirty words. They gave us a midpoint before. Didn't we end up using the definition of midpoint? If they give me a bisector, take a wild guess what justification we'll end up using. Definition of bisector. If they give us a circle, just for future reference, take a wild guess what justification we'll end up using. Definition of circle. It's just that easy, but it's weird because we want to try to mark everything before we write it down. Here's all they gave me, correct? That's it. Is there any non-dirty information given to us? Nope. So we'll go straight to the picture and mark what this means. If ray DB bisects angle ADC, mark that in the picture for me. I'll give you a chance to do that. Angle ADC is this guy, correct? Didn't this dude, ray DB, bisect it? So where do the arc marks go? In here and in here. Notice how I staggered them also, so I can tell there's two different arc marks. That's what the arc marks are all about. That's what this means. So since we mark it, we better go write it down for step 2. What do you want to call this angle right here? You could definitely call it angle 1, and I pray that you call it angle 1 since they put that 1 in the picture. Could you have also called it angle ADB if you wanted to? Could you call it angle D? Isn't there more than one angle in this picture with D for a vertex? So you'd have to call it by 3 letters. But look at what they want me to prove something about. Angles that are just numbers. So how about we say angle 1 is congruent to angle 2. Aren't those the 2 that we put in there? You with me on that? Reason for it. Why did we put those arc marks in there? This told us to, correct? And isn't that what that word means? That is the definition of bisects. How are we feeling so far? I can tell some of you are doing very well, but the people who are just kind of quiet, are we doing all right? Cool? Got a dirty word? Used it. Correct? If they give me a bisector, I better use definition of bisector. Check. Done. Now let's look at what we want to prove. Angle 2, the same as angle 3. So I want to start talking through this. This is how you're going to have to learn to do these on your own, because when I go away, this is a much harder process. So angle 2 is supposed to be the same as angle 3, correct? Let's see what we have written down so far. Have we written anything down about angle 2? Yes or no? We have. Have we written anything down about angle 3? So maybe that means that I should pay attention on angle 3 in this picture and just see, well, what do I know about angle 3? Here's angle 3. Is there anything that it should be the same as in this picture? Why would angle 3 and angle 1 have to be the same? What kind of angles are they? So since we have a reason for that, right, vertical angle theorem, can't we just write that down for step 3? What did you want to say? That what? Angle 1 is the same as angle 3. Could you say angle 3 is congruent to angle 1? Could you switch them around? That means nothing. It's all good in the neighborhood, right? That's the symmetric property of congruence, which says it makes no difference. What was the reason for this? Why was angle 1 the same as the angle 3? They're vertical angles. So vertical angle theorem. I still want us to be able to spell vertical correctly, so we'll write it out. Once you've proven to me that you can spell that word right, we'll start to abbreviate it. But vertical, C-A-L. And then if you put it in your proof, it has to be marked in your picture. If you put it in your proof, it has to be marked in the picture. Angle 1 has to be the same as angle 3. Does angle 1 already have an arc mark in it? So how many arc marks should angle 3 get in it? And I will tell you, that's the number one thing that I'll mark wrong on all your proofs, is you didn't put that stuff in your picture, right? You got it in the proof, but you didn't put it in your picture. Cool? So now let's reevaluate. I got angle 1 the same as angle 2. I got angle 1 the same as angle 3. And I'm trying to prove angle 2 is the same as angle 3. Correct? Well, let's look in our picture. Here's 2. Here's 3. Are they marked the same? That means that something should cross out in our proof. If you got them marked the same, but it's not written in your proof yet, what can we cross out? Peace out, Girl Scouts. All right? Step 4. What's left over is angle 2 congruent to angle 3. And I'm going to pick on somebody. How come that I can cross those out and write the leftovers congruent to each other? Chance. What's that called? Transitive property of congruence. Right? The transitive property of congruence says so. Got a question for you. I'm not going to be that big stickler. Let's say you wrote this instead. Isn't that totally legal? Like if you cross these out and wrote the leftovers and you said angle 3 is congruent to angle 2. Just because this and this are backwards, I'm not going to make you end it and make them switch around with the symmetric property. This and this are the same thing to me. Does that make sense? Like we don't have to do that symmetric property all the time. It's just nice to know that you can make them switch around if you wanted to. Sound okay? Cool? We did dirty word proofs on the front side. To the back side. Is this a dirty word proof? No, it's all about what they give you, right? They did not give me a midpoint, a bisector, or a circle. So here's what we do in normal proof. This is a normal proof. We read the given, write the given, mark the given. Get her done. Read the given, write the given, mark the given. Read the given, write the given, mark the given. We've read the given, we've wrote the given. Now I got to mark the given. First of all, what does this even say? This angle A is congruent to angle ABC. How do you mark angles congruent to each other in a picture? What kind of markings do we need to put in there? Definitely arc marks. Tick marks are for segments. Arc marks are for angles. Correct? This guy. Angle A. Only one letter. What does that mean about that one letter A? It's the vertex of that angle. So isn't this point A right here? Do you see this dude right here? Is that angle A? You bet, because A is the vertex. So arc mark. This guy, angle ABC. Correct? What is the vertex of angle ABC? B. So the arc mark has to go by the B. It's got to go by the B. And would this work? Is that angle ABC? No, because that's angle DBE. You with me on that? Would this work? That's angle ABD. I want ABC, so if I highlight from A to B to C, isn't that angle ABC? Arc mark goes on the side of that. Cool? So non-dirty proof. Read the given, write the given, mark the given. We have accomplished that. So far, so good. Look at what we want to prove. That's our next move. Read the given, write the given, mark the given, then look at what you want to prove. I want to prove angle A the same as angle BDE. Let's think about it. Have we mentioned anything about angle A yet? Have we? Have you written anything down about angle A yet? Yes? Have you written anything down about angle BDE? Nope. And this is a typo, so we probably better change this. This should say angle DBE. Not bad. I got typos all over this thing. Sorry about that. That should say angle DBE. Apologize for the typo. Let's start over. Have we said anything about angle A? Yes. Have we said anything about angle DBE? Yes or no? No. So I'm going to find angle DBE in my picture. If you need to highlight, highlight. If you don't, you can use a pencil. But isn't that angle DBE in that picture? Cool? Can we say anything about it? It's congruent to angle B. There's a lot of angle B's in this picture. These two. Something special about them. They're located right across from each other, correct? Vertical angles, right? So let's write it down. Step 2. This angle that we're talking about, isn't it angle DBE? It's congruent to what? Angle ABC. How come? They're vertical angles. And the vertical angle theorem says, yes, sirree, Bob. Nice. You tell me what to do next. I know this is still new to us, but you tell me what to do next. What do you want to do? Can't cross them out yet? That'll come later. Definitely have some ABCs the same, right? We can cross those out, but not right now, because that's not the next thing we've got to do. It's the number one most forgotten thing in any proof ever done. Mark what you just wrote down in the picture. Don't we need to mark angle DBE congruent to angle ABC? ABC has one arc mark in it. DBE should get the same amount of arc marks. Cool? If you write it in your proof, it must be marked in your picture. Cool? Next thing. Now, do you notice that what we're trying to prove, we go back to what we want to prove, A the same as DBE. Don't they have the same amount of markings? That means that something can cross out. And what are we crossing out? Leftovers. Angle A is congruent to angle DBE. Transitive property of congruence says so. Have we proven what we want to prove? So let's we've done 3 of them now. Let's talk about how they will work every single time. First steps are always free, right? It's the given. Then, for however many steps you do, that's how many points this is worth. This is worth 6 points right here. Aren't there 3 here and 3 there? What will you end with every single time? If you start with a given, what will you end with every single time right here? Whatever you want to prove, right? There's also points for marking the picture correctly. There's points up there. Now, all 3 of the proofs we've done so far, the last property has been transitive property. Do you feel that every single proof we will ever do will end with the transitive property every time? No. Today we're learning about transitive proofs, right? So they will, but not every proof that we'll ever do ends with the transitive property of congruence. We just did a bunch of them that were due today that didn't end with the transitive property, correct? The ones you turned in for homework. Last one. Is it dirty? It's double dirty, right? Double dirty. So we read the given, write the given, but don't mark anything. I'll give you a chance to do that. So we've got our dirty information. Do we have any non-dirty information given to us? Nope. So here's what we do. We move one dirty word at a time, and we mark what they mean. Here, ray EB bisects angle AEC, right? Well, I'll help you with my highlighter, if that helps you. AEC. Isn't that this guy right here? So what would I do in my picture if ray EB, that black ray right in there, bisected that angle? What would I do? Mark it and write it down. Booyah! Booyah! Then we write them down immediately. Dirty words. You mark them one at a time. You write down what we marked. Name this angle for me, Mitchell. What is the name of this angle right here? Which one do you want? Angle AEB. Why does E have to be in the middle, my friends? It's the vertex. Cool. What do we want to put right here? It's congruent to. And then what's the name of this angle right here, my friends? Angle BEC. Reason, anybody. Why did we put those markings in there? Definition of bisects. They gave me the word bisects, so I used it. How many bisectors did they give me, though? 2. How many times have I used it? It means I still got one more to roll with, correct? I got to do this guy right here. So far, we've got this, right? Now, I don't want to do this. Now, let's roll with this. We've got ray EC bisecting angle BED. So I'm going to grab a new color, and here's angle BED in blue, right? Doesn't this blue angle get bisected? Correct? So, shouldn't these two brothers be the same? I know my highlighter kind of made a mess of things, but this already has an arc mark in it. Should this get the same amount? Yes or no? You bet. Single arc mark right there. And now we need to write down these two guys' names. Name this guy for me, the one in here, this guy right here. Angle BEC. Time out. Can you call it angle CEB? Could you call it that? Angle CEB? Okay, I'm going to do that. You just keep doing what you're doing. I'm going to call it angle CEB. Isn't that a legal name for that thing right there? Cool. And then this guy's name is what over here? Angle CED, correct? Could you call it angle DEC? Could you call it angle E? Nope, but I'll call it angle CED. All good in the neighborhood? Reason, definition of bisects. Wasn't that our other bisector right there? They gave me 2 bisectors. Bada bing, I got 2 definition of bisectors in there. Sound cool? Now, we look at what we want to prove. When we have dirty information, we should always write it, then go mark them one at a time, trying to prove this. Let me get this guy right here, orange. Trying to prove angle AEB, this dude right in here, the same as angle CED. Are they marked the same in my picture? That means something should cross out. Now, I know yours is written different than mine, but I did this on purpose to show you the old optical illusion that happens to many kids. Something's supposed to be in common, but it sure as heck doesn't look like I have anything in common. What do I have in common? Isn't this dude and this dude the same thing, really? Isn't E in the middle and B and C are the other 2 letters, right? So even though I didn't write them the same way, they're still the same thing. They can be canceled out, and we write the leftovers congruent to each other. That's not what I want to do. So step for angle AEB is congruent to angle E B. Transitive property of congruence says we gain